Hello, ms.Sobec. So let's start with the first thing. Here we have a structure. The structure is 2,4-hexadiene, and this is its 3D shape. So as we can tell here, because of the 3D shape, we see that this structure is nonpolar. And because it has two alkenes and 10 alkane bonds with the hydrogen and the carbons, we can say that the boiling point of this um, molecule is relatively high because there are 6 carbons, which increase the boiling point, and there are a lot of alkane bonds, which means that it's somewhere around 200, sorry, somewhere around 200 degrees, maybe a little bit higher. Now let's go on to this page. Right here, we have two equations. First equation is going to have this structure plus 2 iodine, and this is our answer right here. We are going to replace one of the hydrogen bonds with an iodine, and then one of the other remaining iodine is going to bond to the hydrogen and be a byproduct. This is the final product and how it's going to look like. It is an alkane that got transferred into, that became an alkyl halide because we added a halide right here. Second equation, we have an oxidation equation where this alcohol became an aldehyde by breaking the bond between the hydrogen and having a double bond with the oxygen, which is an aldehyde. This part looks exactly like an aldehyde, and this part is where the alcohol is. And then we will have a byproduct of hydrogens, and that's how it's going to look like. Then we have this Jamboard, which has a lot of examples of naming these structures. So right here we have 4,5-dibromo-6-nitro-2-heptene. How did we come up with this name? First, we started with the parent chain. We have 1, 2, 3, 4, 5, 6, 7. So it means we're going to have a hept. And because we have a double bond right here, we know we have an ene. The double bond is going to be at the second position because we want the double bond to have the lowest position possible. And then we're going to have 2 bromos right here, 2 halides. They're going to be at position 4 and position 5, so it's going to be 4,5-dibromo. And then we're going to have a nitro right here, so it's going to be 6-nitro. This is that structure. Now let's look at this. Here we have a name, and then we're going to make our structure right here. So we started with pentanol. Because there is pent, we know there's going to be 5 carbons. It's 1, 2, 3, 4, 5. And then we know there's an ol, so there's a primary alcohol right here. And we know that it's in the second position. And then we have a methyl group right here. We can draw it in a different way, but this is how I chose to draw it. Let's move on to this polymer worksheet. In this exercise, I evaluated and analyzed different pieces of clothing, which I gathered from my closet, and what they were made of. They were all made of polymers, either in fabrics, like nylon, like polyester. And here we have plastic products. We evaluated the environment impact by asking the question, can it be recycled? And then we determined if it was recyclable, if it's good for the environment, or if it's not recyclable and could be harmful for the environment. Thank you.